Hello friends! A warm welcome to all of you. If you have clicked on this video, chances are that you have felt that buzz, that electric pulse of the possibilities in the world of AI. But maybe you have also felt a bit of FOMO. Are you watching the AI revolution unfold and wondering, am I missing out? Do you have basic programming knowledge but feel unsure how to take that first step into AI? Are you curious about building apps powered by large language models? The great term of today, right? Apps that can automate your daily tasks, respond intelligently, and even help others? If the answer is yes, dear friends, to any of these, you are at the right place. This video is your launchpad. We are going to demystify the world of AI programming, starting with the basics, guiding you through hands-on examples and showing you how to build real, useful applications using LLMs. No jargons, just clear, practical coaching designed for curious mind like yours. So grab your laptop and let's begin this journey together, from code to cognition, from curiosity to creation. So friends, today in this first video, let us try our hands on building a very simple large language model application. And in this video, we will cover some of the important and very preliminary steps involved in starting to explore large language models and build a simple application based on those models. So the objective of the application that we will build today, the AI application, is given a movie name, the model will return to us some additional details about that movie, such as its director, the year of release, and the genre of the movie. So through this experience, we will be able to see hands-on what are the most important steps in beginning to build AI applications. So let me quickly bring up my screen. All right, so let's look at what are the key steps that we will follow to build our first large language model based application. And I will walk you through practically each of these steps too. So the first step is to set up our basic development environment. Now, all of us know that if we have to build software, and in this case, the AI application, we definitely need a basic environment. So we will look into a bit more detail in terms of what is involved in setting up a basic environment for our development. Once the environment is ready, the next step, which is the most exciting step to push us into the forefront of AI application development, is to explore what are the large language models available, how do we choose one of them, and how do we configure the model so that it serves the purpose that we are looking for. So we will get into more details of this step. Once we have the model ready, then we look at one of the most powerful open source frameworks built in Python, which is called as LangChain. And I'll cover a few more details in terms of how LangChain absolutely simplifies building of AI applications when we get to that step. So using LangChain components, we will be able to set up some of the basic steps for using the model and achieving the purpose of getting more details about the movie. And finally, we put all this together into a cohesive application code, which will be our first AI application based on a large language model, and see how it works. So let's jump right in. So what is involved in a basic environment setup? Well, I think most of us know that we need a PC, right? Now, that PC could be a local PC or it could be a virtual machine on a cloud. The advantage of using a cloud is that you can access that machine from anywhere in the world, from any local PC, right? And how would you feel if I say that actually there is an always free cloud virtual machine available for us to use? Well, let me just give a glimpse of it. But if you need more details about how to get something like this, please leave a comment and I'll be very happy to do a separate video to cover that. Well, friends, so it is actually Oracle which provides an always free virtual machine. As you can see here, you can get an AMD compute instance always free and an ARM compute instance always free. And the configuration is pretty decent for doing all kinds of academic AI application development, like the one that we are doing here. And if you really want to explore more, you can go to oracle.com, search for a free tier, and you will get many details. But exact steps to create a virtual machine that can be always free involves a few intricacies. And let me know if you'd like to know more about it. Right? So back to our main topic. So either we set up a cloud or a local PC for our development and then running the AI application. What I have done is, because I have an always free Oracle Cloud virtual machine, I am actually running some of the core components of this AI application on that, and I'll cover that in a bit. Once our environment is ready, we need to have the basic softwares that we need to install on the environment, right? And as you would have already guessed, a lot of the AI application development happens on Python. So it's very important that we have Python installed on our cloud virtual machine or local PC. Now, here is a very important tip. We can actually go about installing various required softwares individually on our environment, but we always run into this complexity of managing the dependencies between various packages. And that's where installing something like an open source distribution like Anaconda can be of great help. Because what Anaconda does is, once you install Anaconda, it automatically installs a lot of the dependent packages, right? And you can actually create virtual environments on Anaconda. So it's actually like versioning your environments, each version of the environment or each environment with a separate version having its own set of softwares with all the dependencies well managed and so on, right? And this is a great feature when we are trying to develop AI applications, especially when we are experimenting or creating multiple versions with multiple models or features and so on. So I would recommend that you should actually install Anaconda. Another important assumption that I would like to share here for this video is that I'm assuming all the application development is happening on Windows environment. So if you are interested to know the steps for a Linux machine, please let me know in the comments and I will be very happy to cover that in a separate video, right? So if you want to know the steps involved in installing Anaconda on a Windows PC, let me know in the comments. I can cover it. Otherwise, you can also go to Google and search for it. You should get pretty simple steps to do the same. Another very important tool that we will use today, as well as in general used by the AI engineers, is the Jupyter Notebook. I'm sure you would have heard it somewhere. So Jupyter Notebook actually makes it very easy for us to collaborate and code AI applications. And one of the most powerful features of Jupyter Notebook is that you can actually store your entire AI application code as a version file, the whole application, right? So you can create multiple versions of the applications by tweaking some specific parts of the application, such as the large language model or certain configurations, and it becomes so easy for us to compare the different versions and choose the best possible run for our application. So Jupyter Notebook is extremely useful. It supports various languages, but the one that we'll be using is the one for Python. And going back to my earlier comment about Anaconda, Anaconda has Jupyter Notebook inbuilt. So when you install Anaconda, Jupyter Notebook also gets installed, and you actually get something called as an Anaconda Navigator, which is a user interface from where you can launch many of these tools directly from the UI. So you can launch Jupyter Notebook as well. Another important point I want to communicate about Jupyter Notebook is it's actually a client-server architecture. So the server basically runs on the local PC on the local host, and then we access the interface of Jupyter Notebook through our web browser. Now, here is where it's very beautiful when we have a cloud instance. So for example, in the example that I'm showing today in this large language model application, I'm actually running my Jupyter Notebook server on my Oracle Cloud instance. And I'm launching the user interface on my local PC using web browser on my local machine. So the advantage of that is actually I can access my Jupyter Notebook and all the code that I've written from anywhere, from any machine, so long as I am able to launch a web browser on that machine and access that localhost URL on which my Jupyter Notebook server is running on the cloud. So if you need more details about how to achieve this and how to configure Jupyter Notebook for that, again, let me know in the comments. I'm very happy to do a separate video. All right. So we have our cloud and local PC ready. We have the most important softwares, Python and Jupyter Notebook installed on that cloud or local PC. Then there is another very important dependency that we should be aware of, and that's step number 4 in the basic environment setup. And that is, if we are running this on a Windows environment, some of the core packages, for example, the LangChain package that I spoke about earlier, they have a dependency on Windows specific build tools when we are running the Python code through Jupyter Notebook. And in particular, there is a need for the Visual Studio Microsoft Desktop build tools to be installed on our Windows PC. So there are some intricate details about doing this, which I'll not cover in the interest of time in this video. If you're interested in knowing that, please let me know again in the comments and I'll cover in a separate video. But just to give a quick hint in terms of how to achieve this, you can go to Google and search exactly for this Windows Desktop Build Tools installation, and you will get links to Microsoft official website where there are some clear instructions in terms of how you can install this. And when we are running Python code through Jupyter Notebook and using packages like LangChain, which I'll talk in a bit, then they specifically look for the availability of some of these build tools locally, and only then the run for the Python code is successful. All right. So again, to quickly summarize, the environment setup involves ensuring we have either a cloud virtual machine or a local PC. We have Python installed on it. We have Jupyter Notebook installed on it. And we also have the Windows Desktop build tools installed on it, so that then we can go to the next step of starting to look at the other features and starting to write the LLM based code. All right. Next, which is, as I said, the most exciting, is how do we choose and configure our large language model. All right. So the first step in this process is selecting a model host. Wait, what a host has to do here? Well, it's not that easy to directly start using a large language model. Of course, there are tons of models available there in the open, such as the Meta Llama model, the Google Gemini models, of course, OpenAI, GPT models, and so on. But it involves a lot of complexity for us to use the model using APIs, because probably all of us are very familiar with using the conversational interface of many of these models, where it's a chat application and we go ahead and type what we want the model to do and we get answers back. But in this case, it's a program. So we'll have to make an API invocation on the model. So there are some subtle steps involved there, which I will talk about and also show you. But the concept of a host essentially means that there are many services available in the market where we can use their pre-built configurations to make API calls on models. So two examples that I can give today in this video. One is Hugging Face. So Hugging Face has something called as an inference client, which actually allows us to select beneath that inference client any model out of all these models that I spoke about, and then makes it very simple for us to make an API call on the model using this inference client. But Hugging Face is not very generous. So we get very limited free service to use. So after a few invocations on the model, we run out of the free credits and then we'll have to go for a paid subscription. Another such host, which I'll be using today in this application, is called as Open Router. Open Router is a lot more generous because through Open Router, we actually get a lot more free, almost like always free access to some of the models. So let me cover Open Router in a bit. And when I do that, I'm also going to cover how to choose and configure the model. So let me take you to the Open Router interface. When you go to Open Router website, which is openrouter.ai, you will actually see this opening homepage, which is quite self-explanatory, that Open Router actually allows us to access many of the large language models available there in the market, right? So first, let me show you how to choose the model. So if you click on this models link, what you will see is there are a lot of models listed, but not all of them are free. So for example, in today's application, I am using Meta Llama free model. So you search for Llama free, and then you can see the models that are free for use. So not restricted by any paid subscription. Okay. Now, when you click on this, the only information that you need to be able to run or access this model is this particular string that you see here, which is called as a model ID. So I'll come to that, how we are going to use. Now, this is the first important point. When we are choosing and configuring a model, we search for the model that we need. We click on that model. And all this is for Open Router, by the way. There are similar ways to achieve through Hugging Face and the other services that are available. So in Open Router, you click on the model once you have found the right model through search, and then you have to copy this particular string, which is the model ID, and use it in your code to be able to make an API call on the model. Now, the next important step in being able to use the model is we need to have credentials. We need to have authentication on this host, Open Router host, because we need to be a valid user to be able to access the model. And for that, we need to use something called as API keys, right? So when we have to create an API key, you have to go to this menu over here, click on keys, you reach this page, and then you will have to hit this create API key button. And then you can basically enter some name for the API key. The rest are optional. And then once you hit create, what it does is it actually creates a unique key for you as an individual, and it gives you an option to download the key. And the key is basically a string, which again, you will use in the code, right? So I'll not generate it now because I already have one, but I just wanted to show you how to use Open Router. So if we go back to our steps, so what we have done, essentially, we have selected the model, which is the Llama model, using Open Router as the host. And we have got two important details from Open Router, which is the configuration for the model, the initial configuration. One, which is the model ID, which I showed you, and the second, the API key. And when we go to the actual code, I will show you these in more detail. All right. So now we have configured our model. What's the next step? We'll have to understand the model interface. So how to make an API call on the model. Now, most of the times, the host website, like the Open Router, will show you sample detailed code on how to make an API call on the model using their interface. So like I said, in the case of Hugging Face, we have inference client. Now, in case of Open Router, we actually use something called as requests.post, which helps us make a call on the model. So when I show you the Python code, that time I'll explain this in more detail. But the step 3 essentially involves understanding this interface on the model so that we can make an API call on the model, right? And once these 3 steps are done, we just go ahead and invoke the code on the model so that the large language model returns the intended results, right? So that's about choosing and configuring the model. Moving to the next step, configuring LangChain. All right. Now, what is LangChain? Now, an important point to understand is when we are building large language model based applications, there are quite a lot of complexities, right? It's not that simple, right? All the configurations, all the steps, all the code that we need to write, all the objects that we create, they are long, complex steps. And we need a framework which can simplify this process of building a large language model application. And that's where a framework like LangChain comes as absolutely God's gift, I would say, or we can say a gift for all the AI developers. So LangChain is an open source framework built in Python, and it has a very powerful feature called as AI chains. Chain, right? Chain basically means a lot of entities connected together, chained together. And that's what LangChain does. So it's a very modular framework where it allows us to apply what we call as a chain of thought processing, which is nothing but breaking a complex problem into steps. And that's what we often need when we are building a large language model application. Because if we are doing it manually, then it's our brain. And it's quite natural for us as humans to break down complex problems into steps for solving. But how do we achieve the same with the model when the brain is the model? That's where LangChain is of great help. So let me give you a very simple example. When we are building an application like this, where we are giving a movie name, and then we want some details of the movie from the model, there are basically three important aspects here, right? One is the input, right? Which is the movie name going into the model. But it doesn't work just like that. We need to format this input string into the model in such a way that the model can give us the best possible accurate response. And that's what is called as a prompt. And a lot of us are subconsciously or unconsciously using the concept of prompt when we are using the conversational versions of all these large language model based applications, such as ChatGPT. Because what we type on the chat interface is nothing but a prompt. But this whole approach of generating prompts is a very intense and in-depth field called as prompt engineering, right? And it's very important because it's heavily influenced by the domain. It's heavily influenced by the specific tasks we are trying to achieve with the model. So the prompts have to be designed based on the intended output, its domain, its context, and so on. So LangChain provides some very powerful classes and features that help us build reusable prompts. So for the discussion now, let's assume that prompt basically contains the movie name that we want to pass on to the model with some additional configurations. And that becomes one element of this AI chain. Now, this object or element needs to be fed into the model. So we need the model. And we just saw just a few steps back how we can choose and configure a model. So that becomes the second element of this AI chain, the model itself. And the third element of the AI chain is once we get an output from the model, we need to be able to consume that output. And most of the times, the output that we get from models in such applications may not necessarily be easily consumable by downstream applications. It's not about us visually seeing it. That output needs to be fed into some application. For example, once in our case, the model gives the details about the movie, such as the genre, director, year of release, and so on, we may need to feed that information into a user interface to display to the user. Or we may need to feed it to another downstream application or another model where we may need some additional details. For instance, which other movies the same director has directed. So it's a continuous chain, right? So the important part here is for us to make this model output consumable by downstream applications, we need to format it. And that's what is called as converting the output into a format that can be consumed. And LangChain has some very, very good features to allow us to do that formatting through the concept of output parsers. So we spoke about three elements in the AI chain here: the prompt element, the model element, output parser element, right? Imagine if we connect these three, what we get? We eventually get the output that we need. And LangChain not only provides very easy to use classes and modules to achieve elements like these, but also helps connect them into reusable and extensible chain. And you can notice already that each of these are modules. So LangChain is very modular, and it's very easy for us to make changes to each of these elements. We can change the prompt, we can change the model, we can change the output format. One format could be JSON, other format could be comma separated value, and so on. So we need a lot of configurability, extensibility into each of these elements, and that's where LangChain comes as a big help. All right. So let's move on. Once we have understood which LangChain packages and classes we have to use in the context of this particular application that we are developing, we are going to focus on two specific LangChain packages. So the next steps are to understand those packages. So the first class that we are going to use from LangChain is prompt template. So if you remember what I just said a few seconds back, is that we can actually convert the text that we are giving to the model as a prompt into a reusable object, which can be easily configured. And that's what is prompt template. We'll see more about it when we see the code. The next class that we're going to use from LangChain is the JSON output parser. And this is pretty self-explanatory. It's the same output parser concept that I explained in JSON format. So we will get our output in today's application as a JSON. And finally, once we have identified and gotten all these specific classes from LangChain, we just create the code for usage. So that's all about configuring LangChain components. Then comes the real most important step, which is building the LLM application. What are the steps involved? We have to install all the required packages. So we saw we need LangChain, we need prompt template, we need JSON output parser. We have to use Open Router, which also needs certain packages to be installed for us to be using all of them into our LLM application. So we have to install all the required packages. After we have installed the packages, we have to import the required modules, classes, and so on. And then we'll have to write reusable code that will use these modules to achieve our application. And here I need to make one very important submission. What we create in today's video, it's not a production grade code, and that's not the intention. The intention of this video is that we learn hands-on how to build our first large language model based application. So it's more academic, but I'm sure it lay a very strong foundation for all the viewers in terms of getting that fundamental understanding and then making that code robust with error handling, exception handling, handling all sorts of security features and so on can be an easy add-on and learning. And once we have created this entire LLM application code, we just run our application. All right. So now let's quickly jump into the actual code. So if you see, when you launch the Jupyter Notebook, if you remember, I said the UI or the interface through a web browser, you will see an interface like this. You will see all the Python code you have written. So you can see it's basically IPython notebook. The file extension is IPYNB. So when we create a new IPYNB file, or let me put it this way, when we create a new notebook using the Jupyter Notebook, the type of that file that gets created for the Python environment is IPYNB, and we can download this file and we can share it with our teams, our colleagues. So that way it becomes a very collaborative development. There are many other features of Jupyter Notebook as well for collaboration. If you are interested, let me know in the comments and I can cover in a separate video. But for today's interest, what we will do is we will look at the code for our application, all that we have been talking of so far. Yeah. So this is my Jupyter Notebook. So first, I will just scroll through for you to see how the interface looks and how actually you can see the code getting organized, right? So the first step is we have to install, if you remember, all the required packages. So requests is a class which we need for using Open Router, right? And if you remember, I mentioned that we have something called as a post interface. So on request, we have to do a post, and that's how we access the underlying Llama model. Then we have to use LangChain. I spoke enough about LangChain. So these are the two main packages that we have to install to be able to use prompt template and JSON output parser, LangChain and LangChain core. So I've already run this on my cloud instance. So all these packages are installed. Then the next step is to import the required classes. So we import requests, we import prompt template, we import JSON output parser. And we also import JSON, which is an inbuilt Python class, because we are going to use some of the features of that as well, which I'll explain. Let's jump to the main application first. Looks like the previous output is visible here. So let's take that out. All right. So this is the main function of the Python code. And the movie that we are going to test this against is Inception. An important point to note is that here I'm hard coding the movie name because it's an academic code, but there are some very, very strong UI based packages and features available for us to build a simple user interface on top of our AI application. And we can accept inputs such as this movie name from users. And as well, we can demonstrate the output details on the user interface. So there are very good software such as Flask and Gradio. If you are interested, let me know in the comments and I can cover separate videos for explaining more about those. We could also build this as a command line based application where we can request for these inputs on the command line interface and the user can specify movie names and so on. All right. So we're just invoking the main function. And as you can see, the first method call here, which is happening, is generate movie details, passing the movie name. So let's look at what that function does. So it takes the movie name, as you can see here. And here comes the concept of the output parser that I already explained. So that's JSON output parser. It's basically a pedantic object. So if you want to know more details about this, let me know. But at this point, let's keep it simple. Essentially, we define the format in which we want the output. So we just give Inception as the movie name or whichever other movie name. And we expect the model to give us an output in this form. Title of the movie, director, year it was released, and the genre, right? So we have to create what we call as format instructions to instruct the model that the model has to give us output like this. And this instruction will go through the prompt, as I already explained to you, because prompt is the way we interface with the model. So this input will go into the prompt template. So we'll come to that in a minute. And we are specifying some constraints so that we exactly get output in this format. All right. So the next step, as I just alluded to, is creating the prompt. So we have a function called create prompt template, which takes this format instructions and the movie name. So let's see what this function does. So the first thing it does is basically it creates a prompt template object, which I spoke about. This is a LangChain class. And the input to it is the text, which is the same, instructing the model that the model has to behave as a JSON only assistant. And the model has to generate information about the movie, our movie name, and then we pass on the format instructions, which talks about the JSON format. Now, one important thing to note here is you will see this input variables as one of the parameters in this prompt template constructor, and it takes the string called movie underscore name. So it's important that we exactly use the same text when we assign the movie name which is going to replace this text, right? Because that's the way prompt template works. And then format instructions, which have already come from the previous function. So to achieve that, what we have done is we have taken this movie name, assigned it the value of the movie name, which came as a argument to this function. And we are just printing to ensure that the prompt does contain the movie name that we want. Now, because we are using JSON, we need to convert this prompt object into a string, because the prompt template object is not JSON serializable. So we have to convert it into a string, and that's what you see here, rendered prompt. So we invoke the method prompt the underscore template dot format, passing on the movie name, and then we use json.dumps, okay, passing that rendered prompt. So essentially what you're getting here is a string which represents the same prompt, and this prompt has clear instructions for the model to generate the output in JSON format and also generate information about the movie based on the string that we have passed. All right. So once we get this, this is going to get stored in this movie prompt. The next method that gets invoked is invoke model, where we pass this JSON output parser and this prompt string. So let's see what the invoke model does. And this is the most important function. So as you can see, the first thing is we have to initialize the model ID. And if you remember, that's what I showed you here. So if you go to the models from Open Router, search for Llama free and any of them, right? Just click on one. This is what is the model ID. So you just need to copy that. And when you come back to the code, that's what you paste here. So we initialize the model ID. API key, as I explained earlier, it's a unique secret credential of you as an individual. So that's what you type here. And then because the model is hosted on Open Router, we need to know the URL. It's as good as making an API call on a URL, right? So we need the URL endpoint where we have to make the call. So that is this API URL. And then for this particular instance of Open Router for Llama, we'll have to initialize the headers. And as you can see, the authorization basically takes the API key to authenticate us. And then it says the content type is JSON, output has to be JSON. Then we define a payload where we pass on the model ID. And this is an important part, right? We are passing messages to the model. So basically, you will see there are different kinds of messages that can be passed using the LangChain features like prompt template. So a system role essentially tells the model how to behave, right? So here we are saying, model, you have to be a movie assistant. Now, if we reuse this code for getting similar details for a book, right? Given a book name, who is the author, which year it was published, what's the genre, and so on, we could say you are a book assistant. So we can change the role assignation to the model. But the moment we do that, the model becomes a lot more contextual and gives more accurate output. And then user essentially basically says users like us giving inputs to the model. So in this case, this topic prompt is essentially the prompt, which contains the movie name and few additional details that we saw earlier. So that's basically coming from the user like us. So we call it as user. And you will see there's a specific format here, the role and the content. So this is the way we always pass inputs to a model through a prompt template. Yeah. Then this is a very interesting part, right? There are many important configuration parameters on a large language model. Here, for simplicity, we have shown only one, which is temperature. So temperature setting basically makes the model either very structured and more accurate, or makes it very dynamic and creative. So its value can be anywhere between 0 to 1, and typically values less than 0.5 lead to more structured and reliable output from the model, whereas greater than 0.5 can make the model think very dynamically and maybe give a range of possible outputs being very creative. There are other important configurations as well for a model, such as restricting the number of input tokens to be processed and max new tokens that it can generate while generating the output. Why these kind of configurations are important? Because This is just an academic exercise, but when you are building production grade applications, we are actually using paid subscriptions of the models. And one of the most important parameters to measure the subscription fee is based on the number of tokens consumed, the number of tokens generated. So there are configuration parameters to restrict those. And similarly, there are many other configurations that we can achieve or set while making API calls on the models. But today we'll keep it simple to temperature. This is the most important step in making the API call through OpenRouter on the Llama model, which is request.post, where we pass the URL for the endpoint. We pass this headers, which has the authentication and output format type, and this payload, which I've already explained. And that's the call on the model. So what we get as a response should be containing the details about the movie, and we are just trying to print that. So friends, because in the previous code that I showed, I had not put my API credentials, so that code won't run. So in this exact copy of that code, I have actually entered my API key, which obviously I can't show you. So I'll directly run this code and show you the output. So we are passing Inception as the movie name. And let's see if it runs. Yes, model has got Inception as the movie name. And you can see here very clearly, this is the output from the model, where it calls out the director as Christopher Nolan, year of release is 2020, and the genre as science fiction action. And another interesting thing that you'll notice here is that it is repeating this output. So that's a default behavior of the models, where once we make an API call with the prompt, the model keeps generating output. So in this case, it's duplicating. In other cases, it could actually keep generating more and more content. And that's the basic nature of the model, right? And that's the reason it's very important. We restrict the output tokens using configuration parameters like max new tokens generated that I was explaining earlier. So that's it, friends. You can see it very clearly. It's so simple to build our first large language model based application. And here are the live results. I hope you really enjoyed this journey of understanding hands-on how to build your first large language model application. If you like this video, please do like, comment, share this video, and subscribe to this channel. Thank you so much, friends. Bye-bye.